Good evening, students. Now we shall begin with the probability of event not A from axiomatic approach to the probability. Up to the last class, we had discussed about all the four important points regarding axiomatic approach to the probability. The last one is probability of event not A. But entire theoretical concept already I had finished in the last class. Now we shall begin with the problems on the exercise 16.3. The first problem states that a coin is tossed twice. What is the probability that at least one tail occurs? A coin is tossed twice. What is the probability A coin is tossed twice. What is the probability that at least one tail occurs? The sample space S is given by when a coin is tossed twice, total number of outcomes becomes 4. One is HH, HT, TH, and TT. You are very much familiar with this sample space finding. When the coin is tossed twice. Hence, this implies n of S is equals to 4. And n of E is the required number of the favorable event. That is from our required questionnaire part, the n of E equals to n of at least one tail occurs. At least one tail occurs. One tail occurs means in each outcome associated with T, HT, TH, TT. Hence, total number of the outcomes at least one tail occurs. That's equals to 3. Hence, the required probability of event E is equals to n of E divided by n of S. That's equals to 3 by 4. The second question. A die is thrown. Find the probability of the event. Number 1 is a prime number will appear. Second one is a number less than or equal to 1 will appear. Am I right here? Okay. Once again, recall the question. First, you understand a die is thrown. Find the probability of the events. A prime number will appear. Die is having 6 numbers. Either of the 6 we have to select only prime numbers. Yes? Then the solution. Am I right? Okay. The number of equally likely outcomes when throwing a die is equals to 6. Am I right here? 6. Therefore, n of S is equals to 1, 2, 3, 4, 5, 6 because hence a die is having 6 number of the faces. ಅಂದರೆ ಒಂದು ದಾಳವನ್ನು ಮೇಲಕ್ಕೆ ಚಿಮ್ಮಿದಾಗ ಎಷ್ಟು ಮುಖಗಳು ಏನದ ನಮಗೆ ಕಾಣ್ತಿದ್ದಾವೆ ಅಂತ ಕೇಳಿದ್ದಾನೆ ಅವ. ಆ ಮುಖಗಳಲ್ಲಿ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು ಎಷ್ಟು, ಆ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳ ಸಂಭವನೀಯತೆ ಎಷ್ಟು ಎಂಬುದನ್ನು ನಾನು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆ. Therefore, total number of equally likely outcomes are 6. There are 6. Hence, n of S is equals to 1, 2, 3, 4, 5, 6. prime number of outcomes from throwing a die equals to 2, 3, 5. ಇದರಲ್ಲಿ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು 2, 3, 5. How can you define a term prime number? A number which is divisible by itself only. Such numbers are known as prime numbers. ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆ ಅಂದರೆ ಯಾವ ಸಂಖ್ಯೆಯು ತನ್ನಷ್ಟಕ್ಕೆ ತಾನಾಗಿಯೇ ಅದೇ ಸಂಖ್ಯೆಯಿಂದ ನಿಶೇಷವಾಗಿ ಭಾಗಿಸಲ್ಪಡುವುದೋ ಅಂತಹ ಸಂಖ್ಯೆಯನ್ನು ನಾವು ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆ ಅಂತ ಕರಿತಿದ್ದೀವಿ. ಅದರಲ್ಲಿ ಒಂದು ದಾಳವನ್ನು ಮೇಲಕ್ಕೆ ಚಿಮ್ಮಿದಾಗ 6 ಘಟನೆಗಳು ದೊರಕ್ತವೆ. ಆ 6 ಘಟನೆಗಳಲ್ಲಿ 3 ಘಟನೆಗಳು ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳಾಗಿವೆ. ಅವು ಯಾವೆಂದರೆ 2, 3, 5. 2 ಎಂಬ ಸಂಖ್ಯೆ ಅವಿಭಾಜ್ಯ ಅಲ್ಲ ಅಂತ ತಾವು ಹೇಳಬಹುದು ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರೇ. ಆದರೆ 2 ಇದು ಅವಿಭಾಜ್ಯ. ಯಾಕಂದರೆ 2ನ್ನು 2ರಿಂದನೇ ಭಾಗಿಸಬಹುದು ವಿನಃ ಬೇರೆ ಸಂಖ್ಯೆಯಿಂದ ಭಾಗಿಸಿದರೆ ದಶಮಾಂಶ ರೂಪವನ್ನು ತಾಳ್ತದೆ. ಆದರೆ 2ಕ್ಕೆ ನಾವು ಯಮಳ ಯುಗ್ಮ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆ ಅಂತೀವಿ. ಅದಕ್ಕೆ ಯಮಳ ಯುಗ್ಮ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆ ಅಂತಾರೆ. therefore 2 is a prime number because it is only itself divisible by 2 only. Yes, therefore required probability is equals to 3 by 6. 3 by 6, that's equals to 1 by 2. ಇದು ಮೊದಲನೇ ಉಪಪ್ರಶ್ನೆ. The second sub question is the number less than or equal to 1. ಇದರಲ್ಲಿ ಒಂದಕ್ಕಿಂತಲೂ ಚಿಕ್ಕ ಸಂಖ್ಯೆಯರಾಗಿರಬಹುದು ಅಥವಾ ಒಂದಕ್ಕೆ ಸಮನಾದ ಸಂಖ್ಯೆ. ಇಂಥ ಘಟನೆಗಳು ಇಲ್ಲಿ ಎಷ್ಟಿವೆ? ಇಂಥ ಘಟನೆಗಳು ಅಂದರೆ ಒಂದೇ ಒಂದಿದೆ. ಒಂದಕ್ಕೆ ಸಮನಾಗಿರಬಹುದು, ಇಲ್ಲವೇ ಒಂದಕ್ಕಿಂತಲೂ ಚಿಕ್ಕಂತಲೂ ಯಾವುದಿಲ್ಲ. ಅದಕ್ಕೆ ಒಂದೇ ಒಂದು ಘಟನೆ ಇಲ್ಲಿ ದೊರಕ್ತದೆ. ಅದಕ್ಕೆ ನಾವು ಇಂಥ ಘಟನೆ ಇದು ಒಂದೇ ಇದೆ ಅಂತ ತಿಳಿದು ನಮಗೆ ಬೇಕಾದಂತಹ ಸಂಭವನೀಯತೆ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 upon total number of sample species is equals to 6. Okay, this is the second question. Next, forwarding to the third question. A fair coin with 1 marked on the one face and 6 marked on the other hand of a fair die are both tossed. Find the probability that the sum of the numbers that turn up is 3 and another one sub question is 12. Carefully read the question once or twice. A fair coin with 1 marked on the one face and 6 on the other face means coin has 2 faces. On one face it is marked with 1 and other face it is marked with 6. And fair die is thrown. Both are tossed. Then die is having 6 marked numbers 1, 2, 3, 4, 5, 6. It is called dice. A die is numbered on each face, hence it is called dice. Therefore, total number of equally likely outcomes are, here are the 2 outcomes and 6. 2 into 6 equals to 12, that's equals to sample space. It is denoted by S. Hence, the required number of sample spaces is equals to 12. According to his required question, then what is find the probability of the sum of the numbers that turn up is 3. Sum of the numbers that gives 3. Hence, that becomes only the favorable required event is 1, 2. Sum of these numbers is equals to 3. 1 plus 2 equals to 3. how many number 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 like this, 6, 1, 6, 2, 6, 3 like this. Therefore, the required number of the sum of the number that turn up to 3 is only one event which occurs from the set of sample space. Total number of the sample spaces are 12. Hence, we have to select only one group of sample space, that is 1, 2, 1 only. This is one of the sample space. The required probability equals to 1, 2. That's equals to 1 event. Hence, 1 upon total number of sample space equals to 12. In this second sub question is 12. Sum of the numbers that turn up to the 12. Total number of the sample spaces are 12 because 12 outcomes are available when a coin has faces marked with 1 and 6. A fair die is marked with its number. So favorable cases are 12 means only one event which occurs, outcomes occurs 6, 6. The sum of these two numbers equals to 12. Hence, only one outcome is favorable required outcome. Favorable outcome is only one. Hence, required probability equals to n of e divided by n of s. ಅಂದ್ರೆ ನಮಗೆ ಬೇಕಾದಂಥ ಇಚ್ಛಿತ ಘಟನೆಗಳ ಸಂಖ್ಯೆ ಡಿವೈಡೆಡ್ ಬೈ ಒಟ್ಟು ಘಟನೆಗಳ ಸಂಖ್ಯೆ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ನಮಗೆ ಬೇಕಾದಂಥ ಸಂಭವನೀಯತೆ. Therefore, required probability equals to 1 upon 12 because only one outcome which is equals to favorable an event. Favorable event. Okay. Andre 1 by 12, this also 1 by 12. ಎರಡು ಸಬ್ ಕ್ವಶನ್ಸ್ಗಳು ಇದರಲ್ಲಿದ್ದಾವೆ 3 and 12. Yes, okay. Continuing the next question, number 4. There are 4 men and 6 women on the city council. If one council member is selected for a committee at random, how much likely is it that it is a woman? First, you understand the question. In a group of committee, how many members are there? Yes, there are 4 men and 6 women. 10 members committee is there. A city council having 10 members. If one council member is selected for a committee at randomly from the group of 10, a council selects one member as one member randomly, one by one. Therefore, number of members on the city council total is equals to, that's equals to 4 plus 6, which gives 10. Am I right here? 10 members council committee is there. Favorable cases are equals to 6 because what is his required question? How likely is it that it is a woman? Means randomly selecting the 6 members as altogether belongs to the women's in 6 ways. Hence, favorable number of the ways is equals to 6. Means favorable cases is equals to 6 because member is selected for a committee at randomly, that is especially women. 6 women are there. Hence, therefore, required probability equals to 6 by 10. 6 by 10. That's equals to 3 by 5. Am I right here? Okay. Is it understood? Often and often you have to go for the practice these probability questions I think that something already you have studied in earlier classes. Okay, question number 5. Am I right here? Fifth question. What is the fifth question here? A bag contains 9 discs, of which 4 are red, 3 are blue, and 2 are yellow. The discs are similar in the shape and size. A disc is drawn at random from the bag. Calculate the probability that it will be at random from the bag. Calculate the probability that it will be first one red, second one is yellow, and third one is either red or blue. Yes, am I right here? Once again, recall the question. Bag contains 9 discs, of which 4 are red. 9 ಡಿಸ್ಕ್ಗಳು ಇರ್ತವೆ. ನೋಡಿರಿ ನೀವು ಹಿಂಗೆ ಎಸಿತೀರಿ. ಅದರಲ್ಲಿ 4 ರೆಡ್, 3 ಬ್ಲೂ, 2 ಯೆಲ್ಲೋ. ಎಸ್, ಆ ಡಿಸ್ಕ್ಗಳು ಏನಿದ್ದಾವೆ 9 ಇದ್ದಾವೆ. ಆ ಚೀಲದಲ್ಲಿ, ಒಂದು ಚೀಲದಲ್ಲಿ 9 ಡಿಸ್ಕ್ಗಳು ಇದ್ದಾವೆ. ಅದರಲ್ಲಿ 4 ಕೆಂಪು ಬಣ್ಣದ್ದು, 3 ನೀಲಿ ಬಣ್ಣದ್ದು, 2 ಹಳದಿ ಬಣ್ಣದ್ದು ಡಿಸ್ಕ್ಗಳು ಇದ್ದಾವೆ. ದಿ ಡಿಸ್ಕ್ಸ್ ಆರ್ ಸಿಮಿಲರ್ ಇನ್ ಶೇಪ್ ಆ್ಯಂಡ್ ಸೈಜ್. ಅವುಗಳ ಗಾತ್ರ ಮತ್ತು ಅವುಗಳ ಆಕಾರಗಳು ಏನದ ಎಲ್ಲವೂ ಒಂದೇ ಆಗಿರುತ್ತವೆ. ಬಣ್ಣ ಬೇರೆ, ಅವುಗಳ ಆಕಾರ ಮತ್ತು ಗಾತ್ರ ಎಲ್ಲವೂ ಒಂದೇ. The disc is drawn at a randomly from the bag. ಆ ಚೀಲದಿಂದ ಅವಿಚ್ಛಿನ್ನವಾಗಿ ಒಂದು ಡಿಸ್ಕನ್ನು, ಒಂದು ವೃತ್ತಾಕಾರದ ಎಸೆತವನ್ನು ನಾವೇನದ ಹೊರತೆಗೆತಿದ್ದೀವಿ. ಎಸ್, ಆದರೆ ಕೆಂಪು ಬಣ್ಣದ ಏನದ ಸಂಭವನೀಯತೆ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾನೆ. ಎಸ್, here the solution. The number of possible outcomes is equals to 9. Consider the events A is to the disc drawn is red. The disc drawn is red. The disc drawn is yellow, B. C defines the disc drawn is blue. ಹೀಗೆ ನಾವು ಇಷ್ಟು ಘಟನೆಗಳನ್ನು ನಾವು ಈ ಸಮಸ್ಯೆಯಿಂದ ನಾವು ತಿಳ್ಕೊಳ್ಬಹುದು. ಎ ಅಂದರೆ ಕೆಂಪು ಬಣ್ಣದ ಏನದ ಒಂದು ವೃತ್ತಾಕಾರದ ಅಲೆ ಎಸೆತವನ್ನು ನಾವು ಗುರುತಿಸ್ತೀವಿ. ಬಿ ಅಂದರೆ ಹಳದಿ ಬಣ್ಣದ ಅಲೆ ಎಸೆತ. ಸಿ ಅಂದರೆ ನೀಲಿ ಬಣ್ಣದ ಒಂದು ಅಲೆ ಎಸೆತ. ಹೀಗೆ 3 ಡಿಸ್ಕ್ಗಳನ್ನು 3 ರೀತಿಯ ಒಂದು ಸಂಯುಕ್ತಾಕ್ಷರಗಳಿಂದ ನಾವು ಅವುಗಳನ್ನು ಗುರುತಿಸ್ತೀವಿ. ಆದರೆ ಅವನಲ್ಲಿರ್ತಕ್ಕಂಥ ಪ್ರಶ್ನೆ ಮೊದಲನೇದ್ದು, ಕೆಂಪು ಬಣ್ಣದ ಎಸೆತದ ಸಂಭವನೀಯತೆ ಎಷ್ಟು? ವಾಟ್ ಈಸ್ ಹೀಸ್ ರಿಕ್ವೈರ್ಡ್ question? Calculate the probability that it will be a red color. A disc has red color. Yes, the number of red discs is equals to 4. That is, n of A is a favorable required number of favorable event. N of A is equals to red disc. Hence it is 4, because 4 red discs are there. Hence the required probability equals to 4 divided by 9. Required number of favorable events divided by total number of the events. Am I right here? Okay. Next, the second question is the number of yellow discs. How many number of the yellow discs are there? There are two numbers of the yellow discs which are denoted by n of b equals to 2. N of b equals to 2. Thus, the required number of probability of n of b, probability of the yellow disk is equals to number of favorable events divided by total number of the events. Number of favorable events means there are two only yellow discs divided by 9 yellow discs. Am I right here? So this is the second answer. Third one. The number of the event which either red or blue may be described by the set of A or C. A defines red, C is the event defines blue. Either red or blue. It may be red or blue since A and C are mutually exclusive events. Either or. Either red or blue. ಅದು ಇರಬಹುದು ಇರಲಿಕ್ಕಿಲ್ಲ. Therefore, what we have to find, since such events A and C are called mutually exclusive event. ನಾವು ಈಗಾಗಲೇ ಮ್ಯೂಚುವಲಿ ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಇವೆಂಟ್ ಎದಕ್ಕಂತೀವಿ ಎಂಬುದನ್ನು ನಾನು ಪದೇ ಪದೇ ಹಿಂದೆ ನಿಮಗೆ ರಿಪೀಟ್ ಮಾಡ್ತಿದ್ದೆ. ಅದನ್ನು ತಾವು ಗಮನಕ್ಕೆ ತೆಗೆದುಕೊಂಡಿರಬಹುದು. Therefore, A and C are called mutually exclusive event. Yes. ಆದರೆ ಇಂಥ ಘಟನೆಗಳಿಗೆ ಪರಸ್ಪರ ವರ್ಜ್ಯ ಘಟನೆಗಳು ಅಂತ ಕರಿತಿದ್ದೀವಿ. ವರ್ಜ್ಯ ಘಟನೆಗಳು ಅಂತ ಕರಿತಿದ್ದೀವಿ. A and C are mutually exclusive. We have probability of A or C. A ದರೆ ಇರಬಹುದು ಇಲ್ಲ C ದರೆ ಇರಬಹುದು. A or C according to the axiomatic approach of probability which gives the result of probability of A union C. Or A or C is nothing but A union C. A union C. That's equals to, how can you expand A union C? By using the property of probability of axiomatic approach. Some axioms we have studied. By applying the axioms to A or C, which gives the result of probability of A plus probability of C minus probability of A intersection C is eliminated. Already I have derived how the intersection term has been eliminated in the proof of the axiomatic approach. So probability of A union C is nothing but P of A plus P of C, which gives P of A means 4 by 9. A means red, its probability is 4 by 9. Blue means only 3, hence its probability only 1 is there, 1 by 3. Hence, the probability of A is 4 by 9 and probability of C means blue, only one event is there. Therefore, 1 by 3. Hence, means 3 blue discs are there. So that purpose 3 by 9, which gives 1 by 3. Then by simplifying this, then 7 by 9 is the total result regarding either red or blue colors discs probability. Okay. Yes. Okay. Welcome back, students. Already we have solved 5 problems, but the 6th is the homework. All of you write down. Try yourself. I hope you will do the answer. If 2 by L1 is the probability of an event, what is the probability of the event not A? In the last class, we have proved the probability of the event not A from the topic of axiomatic approach to the probability. Is it clear? So follow the proof. First you understand that proof and recall once again. Later on go for solving the question. That is completely based on the fourth point of the probability of axiomatic approach. The seventh question defines here a letter is chosen at a random from the word assassination. Find the probability that letter is a vowel and a consonant. ಒಂದು ಶಬ್ದ ಇದೆ, ಯಾದೃಚ್ಛಿಕವಾಗಿ ಒಂದು ಶಬ್ದವನ್ನು ಪ್ರಸ್ತುತಗೊಳಿಸಲಾಗಿದೆ, ಅದು ಅಸೆಸಿನೇಷನ್. ಶ್ರೀಮತಿ ಇಂದಿರಾ ಗಾಂಧಿ ವಾಸ್ assassinated by a Tamilian lady. ಇದರ ಅರ್ಥ ಶ್ರೀಮತಿ ಇಂದಿರಾ ಗಾಂಧಿಯವರು ಮಾಜಿ ಪ್ರಧಾನಿ ತಮಿಳು ಕುಖ್ಯಾತ ಗೃಹಿಣಿಯಿಂದ ಕೊಲೆಗೈಯಲ್ಪಟ್ಟರು. ಅಸೆಸಿನೇಷನ್. Find the probability that the letter is a vowel. ಈ ಒಂದು ಶಬ್ದದಲ್ಲಿ ಹದಿಮೂರು ಅಕ್ಷರಗಳುಳ್ಳ ಈ ಒಂದು ಶಬ್ದದಲ್ಲಿ ಎಲ್ಲ ಸ್ವರಾಕ್ಷರಗಳಿರುವ ಸಂಭವನೀಯತೆ ಎಷ್ಟು? 13 ಅಕ್ಷರಗಳುಳ್ಳ ಈ ಶಬ್ದದಲ್ಲಿ ಎಲ್ಲ ವ್ಯಂಜನಾಕ್ಷರಗಳುಳ್ಳ ಸಂಭವನೀಯತೆ ಎಷ್ಟು ಎಂಬುದನ್ನು ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ all of you try to do these two questions for your next class homework. I shall begin next with the examples of the number next. Okay, now I am going to wind up your class. Thank you. Try to do homework, and also I have completed your theoretical concept, and also the 16.3 is the exercise going on. Some questions I will solve in the next class. It would be closed in another 2 sessions, means this chapter is over. Okay, good night, bye.